we are going to learn how to measure different properties of electricity in the circuit. We are going to start with measuring current. So here you can see how the 9-volt battery is stronger than the 1.5 volts battery, so the light is brighter. However, the cable and lamps can only handle a certain amount of electrons passing through it, just like a pipe is rated to handle a certain amount of water passing through it or a certain pressure. If it exceeds this, if it is greater than this, then the pipe will burst. Likewise, if too many electrons pass through the cable or the lamp, then they will just burn out the cable. We refer to the flow of electrons as current, and we measure this in the unit of amperes, although you usually use just amps. This is represented with a capital A. For example, this fuse has a 3 and a capital A, which means it is rated for resisting only 3 amps. Current, or intensity of current, intensidad de corriente in Spanish, is measured in amps. And the definition of current is, or the concept of current, to understand it, is to learn that it is how many electrons are passing through the cable at the same time. The most number of electrons passing through the cable, the greater the intensity of current is, and more amps you're going to get. To measure that, you use an ammeter connected in series in the circuit. Okay, so if you want to measure the current in this circuit with 2 lamps connected in series, you can connect this in series, cutting the cable. Okay, or here again you cut the cable and put the ammeter in series with the circuit. Let's see what happens in a parallel and in a series circuit if we measure the intensity of the current. If you measure here, here or there, wherever you measure the current in all this circuit, you are going to get the same, because current, as I have explained, is the number of electrons passing, and you don't lose electrons. The same number of electrons start in the cell and get to the cell again. Okay, no matter how much energy they have, but the number of electrons are the same. So this is why we say that here we measure 2 amps, here we measure 2 amps, or here we measure 2 amps. So no matter where you place the ammeter to measure the current. What about in a parallel circuit? Again, look, the same number of electrons that starts from the cell goes to the cell again, so 2 amps is the measure here, is an example. But what happens here? That there are 2 ways for electrons to pass, and if the 2 lamps we place here are equal, then the intensity of current splits evenly in both branches of the circuit, in both sides of the circuit. So, ready to do an exercise? Look at this. Here you have 2 circuits, one in a series circuit, and here you have a parallel circuit. We consider all the bulbs to be identical. Okay, you have all the lamps identical. What do we have here? We have an ammeter here. Okay, we place an ammeter, and we want to know the reading of this ammeter, right? In a series circuit. Remember that in a series circuit, what you have is the same number of electrons moving all along the connector from the battery to the battery again. They pass through the different devices, but you don't miss any electron. And current, what you measure with an ammeter, is the amount of electrons that are passing through it. So how many amps are you going to get in this ammeter? I'm sure you know it. We're going to see the solution later. Now copy this and try to do it again. Now, what do we have here? Now we have three lamps connected in parallel. As you can see, there are three different loops from the lamp, from the cell or battery to the cell again. So there are three loops because we have three different lamps connected in parallel. Here we put an ammeter and the reading is 3 amps. Good. Now tell me, what is the reading of this ammeter? What is the reading of this one? Knowing that this is 1 ammeter, 1 amp. So, are you finished? Stop the video, do it, and check it later. And here you have the solution. So check the solution with your notebook and be ready to do similar exercises. See you in the next video.